Hello everyone and welcome in a new video, and in this video we are going to understand about the advantages and the disadvantages of FCFS and SJF scheduling algorithm. In the previous videos we understand about FCFS, we understand about SJF. Okay, so now what we are going to do is we are simply trying to distinguish between these two things, trying to find the difference and understanding what are the advantage and the disadvantage of these scheduling algorithm. First of all, let's talk about FCFS. Now, what is FCFS? FCFS is basically first come first serve scheduling algorithm. In this, whosoever process come first in a ready queue will get the CPU first. Okay, so what is its advantages? So advantages is like it's very easy to implement. It's very easy to implement, and this is used practically in systems, FCFS scheduling algorithm. And what are the advantage? It's this FCFS scheduling algorithm logic is not very complex. It means no complexity, no complex algorithm. And what is its advantage? Advantages like no starvation is possible. No starvation is possible. Now, what does the meaning of a starvation? First of all, we have to understand this. So, a starvation. Okay. So, what is starvation basically? Starvation is basically when your process is waiting for the CPU, when your process is waiting for the CPU for infinite amount of time, then we say that this process goes in a starvation. That process basically get a CPU after a indefined amount of time. It get a CPU, but it gets CPU after a very long time. Okay, what happen in FCFS is if a big process is executing, so a small process or the other process which come after the big process will get a CPU after some time. But what does meaning of a starvation is? This is our let's say this is our main memory, and we have CPU, main memory and the CPU. Okay, and we have a process like P1, P2, P3, and P1 is a process who come first, P2 is a process who come second, and P3 is a process who come at third. So what happen in FCFS? Those process who come first will get a CPU first. So P1 will get a CPU, then P2 will get a CPU, and then P3 will get a CPU. So what happen here is process will get a CPU after some time. Okay, what does the meaning of an starvation is? We have a CPU and we have a queue of a processes. Let's say P1, P2, P3 and P4. Let's say P1 process is executing in a CPU. After some time, what happen is P3 process is executing in a CPU. After some time, what happen is, let's say P5 is a process who come in a ready queue. After some time, after P2, what happen is P5 is a process who get a CPU. Because when P1 is completed, so this block will become empty. So this block will be filled by the P5 process. Similarly, when P2 is terminated, let's say P6 is a process who comes. So after completion of a P5, P6 process will get a CPU. Okay, so here you can see that the new processes come and they will get the CPU. So the process who are already in a ready queue will not get a CPU. Eventually it will get, after some time, what happen is P5 is also done, P6 is also done, then there is a chance of a P3 to get a CPU. But this thing take a lot of time. This thing take an infinite amount of time, because we don't know that how many processes will be there, what is their burst time. Operating system does not know these things. Okay, so that's why the process who waiting for the to assign a CPU will not assign. Why? Because there are so many processes who come in a ready queue and get a CPU. How is this possible? Because of scheduling algorithm. There are so many scheduling algorithm who do these things. But FCFS, this starvation is not possible. This is called starvation. and in FCFS starvation is not possible. Why it's not possible? Because those process who come first will get a CPU first. So after P1 execution of a P1, after execution of a P2, because P1 is execute, so this block become empty, and let's say the P5 process now acquire this block. Okay, P1 is execute, P2 execute, but P5 will not execute in FCFS. FCFS says those process who come first will get a CPU first. After P5 comes after P3, so P3 will get a CPU and then P5 will get a CPU. Okay, but in some algorithm this thing is not possible. Those process, the new process will get a CPU. So the process is already in a ready queue for a very long time. They have to wait for the CPU for a very long time, for an undefined amount of a time. So this is what an starvation is. Let's say an example as well, like this is a station. Okay, this is an station and this is your train. Okay, train. So what happen is your station is basically 10 kilometers away from your train, and let's say that your train is basically stop in the middle of a forest. Why it stop? You don't know that thing. You don't know that thing. Okay, so you know that your train eventually put you in a station, but it will take indefined amount of time. You don't know that how much time it will take to basically get an station. Okay, so you don't know that amount of time. Similarly in this case, the process doesn't know that at what time we will get a CPU. Eventually you will get the CPU, but how much time they have to wait, they don't know about that thing. This is what called a starvation. Okay, so what is the advantage of FCFS? No starvation. Starvation is not possible happening in FCFS scheduling algorithm. So what is starvation? Starvation is basically undefined blocking or waiting in defined blocking, or what you can say is waiting, undefined blocking and waiting. And what is starvation? Starvation is a process wait for CPU for how much time? For indefined amount of time, because we don't know that at when the process will get a CPU. So what is starvation related to process? Process waiting for CPU, process waiting for CPU for undefined amount of time, undefined amount of time. This is what starvation is. This is what starvation is. So I hope it is clear to you that what is the advantage of FCFS. Okay, easy to implement, no complex algorithm, no starvation is possible. Now we talk about the advantage. Now it's time to talk about the disadvantage. Now what is the disadvantage of FCFS? That no option for preemption. Disadvantage is what? No option for preemption. No option for preemption means preemption thing is not possible in FCFS. If there is
5% ही चार्ज हुए तेरा वैसे
will get a chance. So what the process will get a chance, but in FCFS what happen is long process will execute for a very long time. So the small process need to wait for basically a long time. So this is what happen in FCFS. For a long time doesn't mean it go in a starvation. Long time means a little long, not like a starvation. Starvation is a very long time. Process have to wait for a very long. Okay, so this is what the disadvantage of FCFS scheduling algorithm. Convoy effect made the system slow, because if a big process get a CPU, so they will execute herself for till the process will be terminate. So the small process will not get a chance, or you can say the other process will not get a chance to execute. This thing will commonly happen in FCFS. Okay, so this is what a FCFS scheduling algorithm advantages and the disadvantages. Now we talk about the other scheduling algorithm, which is called SJF, shortest job first scheduling algorithm. So SJF. Now what is SJF? SJF is basically a shortest job first. What happen is in SJF, we have a CPU, we have a ready queue. In ready queue we have a process, let's say P1, P2 and P3. P1 having a bus time 10, P2 is 5 and P3 is 20. So those whose bus time is low will get a CPU first. So P2 is a process who have a low bus time, which is 5 among these three. So definitely P2 is the process who get a CPU first. After that, P1 process among P1 and P3. P1 is bus time is lower than P3, so definitely P1 will get a CPU, and then lastly P3 will get a CPU. So this is what happened in SJF. Okay, so if you want to solve this numerical, understand this thing in more detail, then you have to watch the previous videos. Okay, or just type SJF scheduling algorithm by code, guys, then you see the video, then watch. Now we talk about the advantage. What is an advantage of SJF scheduling algorithm? So the advantage of this algorithm is that the minimum average waiting time and the minimum average turnaround time among all the non-preemptive scheduling algorithm. FCFS is one non-preemptive scheduling algorithm. SJF is one non-preemptive scheduling algorithm. There are so many non-preemptive algorithm. There is one. These are the two common example, and we have one more like LJF, longest job first, and many more scheduling algorithm who basically follow non-preemption. But if you solve problem with all of the scheduling algorithm, like longest job first, like FCFS, like SJF, or any scheduling algorithm, what is the motto of CPU scheduling? To get a minimum turnaround time and minimum waiting time. So SJF is a one among all the non-preemptive algorithm who gives us a minimum turnaround time and minimum waiting time. Minimum turnaround time and the minimum waiting time. So I hope it is clear to you that why this is an advantage of using SJF, although SJF is not used practically in any way. Okay, FCFS is used, but SJF and one more scheduling, there are so many scheduling algorithm which is basically used to create a questions, not there is not a practical use. But SJF, what it does is it basically set a benchmark that minimum TAT can possible is like this, like let's say 10 for some processes, minimum waiting time is like 5 for some processes. This is what SJF says. SJF basically create a benchmark. SJF create a benchmark for other scheduling algorithm to compare that which scheduling algorithm will give a optimized result. Okay, although SJF is not in a practical implementation, this is used to create a benchmark just. Okay, so what is an advantage? Advantage is like minimum average waiting time, minimum average waiting time and turnaround time, minimum average waiting time and turnaround time among non-preemptive scheduling algorithm. Remember this thing, among non-preemptive scheduling algorithm. Why I said among non-preemptive? Because if we talk about a preemptive scheduling algorithm, then we have SRJF, shortest remaining time first, which gives us a minimum TAT and minimum WT for a preemption case, not for a preemptive case. If we talk about every processes like non-preemption, preemption, if question arise like that, who gives us a minimum W waiting time and turnaround time? Among you can choose from a non-preemptive scheduling algorithm, and you can choose from a preemptive scheduling algorithm. If a question arises like this, then you have to say SRJF, shortest remaining time first, shortest remaining job first. Okay, SRJF is the correct answer for this question. Okay, when we talk about who gives us a minimum, SRTF, shortest remaining time first. If we talk about the who gives us a minimum TAT and WT among all the scheduling algorithm, but if we talk about the non-preemptive, then SJF is the one who gives us a minimum TAT and WT for a non-preemptive algorithm. Okay, this is what an advantage of SJF. Now after that, what is an advantage? Advantage, like it gives us a better throughput in contiguous execution. What it does? Better throughput in continuous execution. Continuous execution. What does this mean? We know about that SJF is that whosoever have a smallest burst time will get a CPU. So what happen is, so many processes are coming in a ready queue, so many processes are leaving in a ready queue. Why? Because those processes who have a smallest burst time, they will get a CPU and they execute very fast. So the the process leaving the CPU and the process will get a CPU. The sequence is basically moving very fast, so CPU cannot become idle in this situation. So that's why what we can say that this gives us a maximum throughput. What happen in FCFS, if long process is going to an IO operation, then the operating system CPU basically have to wait till the completion of IO event of a particular process. So CPU become idle for that time. But here this thing not happen because they have a very smallest burst time. So process will get a CPU, execute, terminate, and other process will get a CPU, execute, terminate. So process are entering in a ready queue and leaving the ready queue. So it gives us a maximum throughput. Because throughput is what? So many processes executing at a unit time. So that's what a throughput basically is, and we have to generate a maximum throughput. This is what a goal of CPU scheduling, and this will basically do that. It will basically complete that goal of CPU scheduling. It gives us a better throughput in a continuous execution. Okay, this is what SJF advantage is. Now we talk about the disadvantage of SJF. Now what is the disadvantage? Disadvantage is like there is no practical implementation. What I said is there is no practical implementation. There is no practical implementation. Why I said that there is no practical implementation? Because the burst time is not known in advance. That's why I said that there is no practical implementation. What does this mean? Let's say we have a CPU and we have a processes in a ready queue. So let's say P1, P2, P3, P4. So these are the processes. So every process have a burst time, but the main thing is what the operating system doesn't know that what is the burst time of P1, what is the burst time of P2, what is the burst time of P3, and what is the burst time of a P4. So if operating system does not know about the CPU, although know, because CPU is executing that process, so definitely CPU will definitely know that what is the burst time of a process, but the operating system doesn't know about that. So if operating system is basically the main thing in a computer. So if the operating system does not know about that thing, then how we can implement this scheduling algorithm? We can't because operating system cannot control these things, because operating system doesn't know about the burst time. So that's why there is no practical implementation of SJF, shortest job first. Okay, and if you want to write the description, so you can write like that, because burst time is not known in advance by operating system. Okay, so why operating system doesn't know about that? So it's basically designed like this. So operating system doesn't know about the burst time. Okay, because how the operating system know about the burst time? Let's say you are you are basically open your phone and you are you are basically using a WhatsApp and you are sending a message because you are in a hurry. What you do, you send a message very fast to your friend. Okay, I'm reaching to you, I'm basically catching you within 5 minutes. Okay, so you do like this. So it's all about you. The operating system think that okay, so he used this particular process for a 5 minutes, let's say 5 minutes. After some time, what basically after day or few days later, what basically happen is you want to talk to your friend, so you open a WhatsApp and you start chatting, and now you spend almost 30 minutes on that process. So here you can see the difference. When you are in hurry, you use only 5 minutes, and when you are free, you use for 30 minutes. So how operating system find that how much time you use that particular process? So definitely don't know, operating system don't know about that, although you know about that, but operating system don't. So that's why if operating system doesn't know about the burst time, then how this thing can be implemented on a system? No, this thing cannot be implemented. So this is what the disadvantage of SJF. So I hope you understand about the disadvantage. Okay, this is a very important disadvantage, you need to remember this thing. And now other disadvantage, like no option for preemption, same in FCFS, no option for preemption, similar case, because it's also non-preemptive scheduling algorithm. So if a process start executing, they will execute, and then the other thing will execute after the termination of a current process. Okay, and what are the other disadvantage? Like longer process may suffer from starvation. Longer process may suffer from starvation. Why I say that the longer process will suffer from an starvation? What is starvation? Basically, process have to wait for the CPU for a very long amount of time. Okay, this is what an starvation is. Let's say we have a queue, and we have a process like say P1, P2, P3 and P4. Now what happen is the burst time is in a sequence like 1, 2, 3, 4. So this thing is happen like this. So whosoever is the smallest burst time will get a CPU first. So P1 will get a CPU first. So P1 is executing because it's have a smallest burst time, so it execute and it terminate very fast. Okay, so when it leave the P2, after that P2 is a one process who have a smallest burst time, so P2 will get a CPU, come execute and terminate. What happen in between this block is become empty, so this block is acquired by, let's say, P5 process. This block is acquired by P5 process because P1 is terminated, and now P2 is also terminated, but the value of P1 is what? 1. Value of P1 is what? 1. So although what the sequence says that the sequence basically says that P3 is a process, P3 is in a queue to get a CPU, but what happen is P5 process come in a ready queue, and because its burst time is very low compared to P3, because P3 burst time is 3 and P5 burst time is 1. So after completion of a P2, what happened? P5 is a process who will get the CPU. P3 is not a process who will get a CPU. P5 is the one who get the CPU because of the burst time, because he's having a smallest burst time as compared to the other processes. P5 come execute, and let's say that P6 is a process who come whose burst time is 1. So definitely P6 is the one who will get a CPU. So this loop will going on till the process is not entering in a ready queue. When process is completed, all the processes are completed and only these two processes are left, then these processes will get a chance to get a CPU. So here you can see that these processes will have a chance to get a CPU, but this process doesn't know about how much time will these processes have to wait to get a CPU. Okay, so that's why these processes will go in a starvation. This is what starvation means. Process have to wait for an indefinite amount of time. So this is what starvation is, and in SJF starvation is possible. Okay, so I hope you understand about these things as well, that why I say that starvation is possible. Okay, so this is all about the advantage and disadvantage of FCFS and SJF. This is a very important thing. I hope you understand these things. So this is all about the FCFS and SJF advantage and disadvantage in this video. Thank you for watching this video. Like the video and subscribe my channel.